Hi, Behnam. Thanks today for coming out to the show. We're really excited to have you. So today we're going to talk about a little more about you and your company. So, yeah, tell me a little bit about yourself and what you're building, and yeah.
Yeah, sure. Yeah, hi, this is Benna, and thank you very much for having me. I did my PhD in electrical engineering in wireless communication systems at the University of Alberta. So I finished the program, and after finishing the program, I started the entrepreneurship fellowship through the Innovation Catalyst grant from the government of Alberta.
What does that do?
That grant is a really great opportunities for the recent graduates across the Alberta province to make their innovative ideas possible from the incorporating the companies, IPs, and also developing and hiring people to increase more job opportunities in the province of Alberta.
I see. So they give you money after you graduate to go and start a company?
Yeah, sure. It's a competitive grant, and after the selection, you will get 250K for hiring and running a business based on your innovative ideas.
Wow, that's really cool. So is your business based on something you did in school?
Yeah, actually, as a course of my PhD research at the University of Alberta, I was able to develop a patent with my PhD supervisor, and then we applied for this grant, and we were selected, and we are developing the business based on this.
I see. So what's the business and what's the research?
Yeah, my company's name is Phase Metron, and we are developing some microchip technologies for 5G communication systems. And in a simpler words, we can say that the technology is about internet satellite communications. In the next years, we need more wireless data communication, and especially if you heard of Starlink, we see that we will have more and more satellites really close to the earth, and we call those satellites as like LEO satellites. So
Neo
those,
satellites?
yeah, the low orbit
Okay.
satellites that are the closest satellites to the earth.
Oh, like not Neo, but like Leo.
LEO
I
satellites, yeah.
see. Uh huh.
Yeah, so it's exactly matches the technology that Elon Musk is developing in Starlink. So we are working on some receivers to track those of satellites and keep the communication reliable and safe.
Okay.
Yeah.
So is it preventing satellites from colliding or making connectivity more reliable? Like, what does it like help with?
The challenge and problem that is for these kind of areas is the satellites are orbiting around the Earth, and you will have 20 minutes wireless communication to one satellite, and then the next satellite comes.
Okay.
So for this process, you should have some receivers that in a like simple point you can mechanically rotate the receiver to track the satellites. But the point is, the satellites are really fast, and we cannot do that. So that the phase shifter and the technology that we are developing comes to the game. So we will, have some phase shifter that make it possible to electronically, instead of physical and mechanically steering the beam of an antenna toward the satellite.
Okay, so in the past, like the best option would have been literally point antenna at satellite in space, but obviously it's a very small satellite and we're very far away, so it's hard.
Yeah.
And then now what you do is you're able to basically point a digital beam instead of like a physical one at the
Exactly.
satellite, and it can be more accurate.
Yeah, actually, the receiver antenna will be fixed, and just using some electronic components and
Yes.
doing some electronic magics, we will do the beam steering. It's actually the technology that has been available, but we are just working on the specific component that we call phase shifter and make it more efficient and also more reliable and fast for this kind of
I
application.
see. So how much more efficient are we talking?
In terms of efficiency, the phase shifter that we have, especially the electronic, efficiency of those kind of phase shifter is gonna be about 40% in the whole system, but we can increase that to the 80-90%.
Wow. So that's really interesting. And how long have you been developing it for?
I started this project through my PhD study, and after the PhD graduation and having the great opportunity of the funding and grant that I had,
Mm-hmm.
I continue working on that, and it's been like 2 years of working at that. Yeah.
Mm-hmm. Cool. So 2 years. And in those 2 years, do you have a prototype or like how far along have you gotten?
We have some prototypes in our lab, and also we are working on designing the antenna, the whole system, the phase shifter. So, and also we have access to the nanofab, and we
Yes.
are, doing some, experimental and fabrication in the nanofab.
Yeah.
So, yeah, we have some prototypes, but we still need to optimize the structure and also shaping the product based on the customer's needs. So at
Mm-hmm.
the same time, we are working on the both marketing and the technology development.
Yeah.
So we will still have some, efforts to make the technology better and better,
Yeah.
but it has a great potential.
Cool.
Yeah.
And do you see a place where you'll be selling? Like, who would you sell it to? Like,
Yeah, that's a great question. In the supply chain, we have different customers. We have the Telos as a shareholder of the company.
mm-hmm.
Telos is the providing the internet and, as you know, the cellular system
Mm-hmm.
for the customers. But the point is, we need to work with antenna manufacturers or some other companies as a partner. So
Yeah.
for some part of my technology, we will need some mechanical actuators. So the mechanical actuator companies can come and have some partnership with them, and also we can also have partnership with the antenna manufacturers,
Mm-hmm.
and with those kind of manufacturers, they can have our phase shifter. And
Mm-hmm.
also we can develop the both phase shifter, beamformer, and the antenna technology, and selling the full product to a service provider like
I
Telos.
see. Cool.
Yeah.
And what got you into phase shifters specifically? Like, why that of all the things to research?
Yeah, that's a great question. I think the reality is when you start a PhD program at the university, the first year is going to be just working and just problem solving and passing those courses
Mm-hmm.
and assignments maybe. And then at the same time, I was able to do more and more research on some specific structures that are called spoof surface plasmon polarizer. That is very technical,
Yeah.
but but the point is, I was working on that and just developing different structures using this kind of configurations. And we found that these kind of structures are really potential for being a phase shifter,
Mm-hmm.
because of their features like really highly localized electromagnetic fields that
Yes.
we can effectively change the phase of the signal.
Mm-hmm.
So because of that, I worked more and more on that, and we got really good results through my PhD, and then we decided to contact the you know the innovation center at the University of Alberta
Mm-hmm.
and applying for registering a patent, and we filed the US patent, and it's the whole story of that. Yeah.
Yeah. Cool. And then, yeah, in the big picture, I know it's still early days. You're building advanced hardware, but if everyone had your product and it was everywhere where it needed to be, what kind of impact could that have on like a global scale?
Yeah, that's a great question. Imagine that you're driving from Edmonton to like some areas for like your holidays, like
Sure. Yeah.
Banff, and suddenly you see that you're losing the internet coverage
Mm-hmm.
because you are in some remote areas, hard to access areas,
Mm-hmm.
and these kind of products helps people to have internet satellite coverage almost everywhere.
Uh-huh.
So, and helps the community to access to the internet and reliable communications in like especially in the harsh winter in Alberta,
Yes.
and also like the First Nation communities, First Nation territories. So it's all about the quality of the communication systems that we can have.
Mm-hmm. So it's like less 3G, 4G, and more of the 5G, basically.
Yeah, it's gonna be more of the 5G, but the point is our technology is compatible with those kind of technology as well.
Yeah.
But because of the frequency band, we have Ka and Ku band for satellite communication, so
Yes.
we will work on 5G. Yeah.
Cool.
Yeah.
And otherwise, how long have you been with the incubator, and have we been able to help you with anything?
Yeah, great. Engineering incubator was really, influential for me because when I wanted to, when I finished my PhD, actually, I didn't know any ideas about incorporating a company, legal stuff, and also different aspects of a company like venture capital,
Mm-hmm.
and how to communicate with investors, what makes investors motivated to invest in your company, what are
Mm-hmm.
the important criteria. And engineering incubator actually with different programs, with different workshops and presentations helped me to work and work on my company and incorporate my company.
Mm-hmm.
So yeah.
Cool. And when did you join now? Was it months ago?
Actually, I joined the ICE Incubator in February 2025. It's been
Mm-hmm.
a year.
Oh, it's like the anniversary.
Yeah. Yeah. So
Uh-huh.
always great atmosphere,
Yeah,
really
yeah.
friendly environment, and always a good place for learning.
Mm-hmm. Cool. And yeah, now we'll just shift back to the company. That have you had any big breakthroughs recently? Like anything exciting that you want to share?
Some of the news are confidential, but
Mm-hmm. What's not secret?
yeah. But the point is, our technology is growing
Mm-hmm.
better and better, and
Mm-hmm.
we increased our team, and we
Oh, how big is the team?
we have some contractors working
Mm-hmm.
on the project, and I think it's enough for the company at this stage.
Mm-hmm.
But we will have more and more job opportunities in the near future for sure.
Mm-hmm.
Yeah.
Makes sense. Cool.
Yeah.
Yeah, it's always interesting talking with people that have, you know, things, yeah, secret stuff. It's like, wow, like, I wonder what you're up to. But no, that's really cool. So, and otherwise, like the core founders, there's your supervisor and yourself?
Yeah.
Yes. And that just the two of you, or is there someone else that's also been really,
Yeah.
involved?
Yeah. That's myself and my supervisor, and
Mhm.
also we have Telas company as a shareholder, and
Mhm.
also universities as shareholder of the company as
Mhm.
well.
Cool. Awesome.
Yeah.
Well, thank you so much for coming out. And yeah, this is really great. And yeah.
Thank you for having me, and I hope I see more and more students incorporating new companies, and I'm excited actually to hear more about them, and I
Mhm.
can help them if it's
Mhm.
possible in future.
Awesome. Happy to hear it.
Yeah.
All right. Okay. Thank you.